everyone, and welcome to day 8 of our programming journey. I am Kirayeshwari, and today we are tackling a foundational yet often intimidating topic in C and C++ pointers. Pointers are like the steering wheel of a car. They don't drive the car themselves, but they control where the car goes. Mastering pointers unlock a deep understanding of memory, efficiency, and low level control. By the end of today's session, we will not only know what pointers are but also how to use them for dynamic memory, reference, passing, and data structures like a linked list. Let's set the stage with the basis what exactly is a pointer. What are pointers? A pointer is a variable that stores the memory addresses of another variable. So instead of storing a value like 10, a pointer stores the location where the 10 lies. Why is this useful? Well, imagine being able to access and modify data without knowing its name, just its address. This gives you tremendous flexibility in coding. Think of a pointer like a delivery driver with a map. The map does not contain the package but tells you exactly where to find it. So when you can say int pointer equal to x, x means address of x. Pointer lets access the value at the address. We will explore this further with diagram and examples. But the key idea is pointer let us indirectly access and manipulate the data. Why use pointers? You might ask if you can just use variables directly when both are with pointers. Efficiently, you can pass address instead of copying large data. Dynamic memory allocates memory only when needed. Function interaction. Function can changeable variable passed by reference. Data structures. Pointers are the backbone of linked list, trees, graphs, etc. Let me ask you, have you ever written a function and wondered why it did not change the original variable? That's because C uses pass by value. But with pointers, we can modify the original without returning anything. This is essential in a real world application, from operating system to embedded systems. Pointer syntax in C and C++. In C and C++, pointer syntax involve two key symbols, star and and. Star is used in a declaration to say this is a pointer and in dereferring to access the value it points to, and is used to get the address of a variable. Ampersand means is used to get the address of a variable. Here an example. Int x equals to 10, int p equals to x. P stores the address of x. Printf prints the 10. Let's break it down. Int star p. Declare p as a pointer to an int. X gets the memory addresses of x. P fetch the value stored at that address, which is 10. This is syntax may seem strange at first, but practice makes it a second nature. We will get lots of the day. Declaring and initializing pointers. It is important not just to declare pointers, but to initialize them properly. Uninitialized pointers are dangerous. They are called wild pointers and they can point to random memory and caching crashes are corruption. Good practice in p equals to null. Save initialization. If you don't wait, have a valid address, use null. This signals to your program and you that are the pointers is not pointing anywhere meaningful yet. Always remember one thing, declare with star to indicate it's a pointer. initialized immediately with a valid address or null. What is happen if you dereference in uninitialized pointers? Answer is undefined behavior and likely crashes. Pointer types. Not all pointers are created equal. Just like how we have int, float, and char type for variables. We also have int, star, float, star, char, star pointers, and each type matters. Why does type matters? Because it determines how much memory the pointer is expected to manage, how pointer arithmetic works. For example, int a equals to 5, int star p1 equals to ampersand a, char p2 equal to char a, even though both p1 and p2 point us to the same address. They interrupt the data differently. Int star read 4 bytes or char reads 1 byte. This becomes crucially when working with arrays or performing pointer match. Always ensure your pointer type matches the data it's meant to work with. Otherwise, we'll get bugs that are extremely hard to trace. Null pointers. A null pointer is a pointer that points to a no memory. Literally, it holds the address 0 or white step. Think of it like a safety net. Before assigning a real memory addresses, set your pointers to null. Why is that point? Because dereferring a null pointer causes a runtime errors, often a segmentation flux. But testing for null help you avoid this. A safe usage example is there under classic C checks. Printf. A quick one of the tip in modern C++ use null pointer instead of null for better type safety. Wide and dangling pointers. This is very thing get scared. Wild and dangling pointers are the variant of pointer program. Wild pointers means uninitialized pointers pointing to random memory. Dangling pointer means points to memory that has been delocated to free. In one of the break these down. Int star while no initialization equals to while. Dereferring these might crashes your program or corrupt data. Now for a dangling pointer, int p equals to int malfunction size of int p equals to 10. Free memory free. P is a red dangling pointer. If you see star P after free, we are accessing memory that no longer belong to your program. Best practices. Always initialize pointers after free. Set P equal to null to avoid accidental usage. Pointer to pointer. A pointer to a pointer is just what it sound like a variable that stores the address of another point. Why is this useful? It allows modification of pointers in functions. It is essential for dynamic 2D arrays. It's a one of the example is there. Int x equals to 5, int star p equals to x, int double star pp equals to p. Here how it works, p points to x, pp points to p. So star pp equals to x. Visualize it like a two-level buildings. First floor pp points to p. Second floor p points to x. This concept is foundational when you work with the array of strings and dynamic matrices and function argument that need pointer modification. Memory addresses and dereferencing. This slide walks us through how address and dereferencing really work. Let's walk through this example. Int variable equals to 10, int pointer equals to where gives the memory addresses of where. Pointer store that address pointer give you back the value 10. Now this is the powerful pointer equals to 20. This is change where directly. That is the essence of the indirection. Now check this out. Printf percentage %p and var. Print addresses of var. Printf percentage of %p and pointer same as var. Print percentage of %d pointer print value 10 or 20. Always remember one thing. Ampersand is address of, star is value at that address. This is understanding to essential as we dive deeper into pointer, arithmetic and dynamic memory. What is pointer arithmetic? Pointer arithmetic allows us to perform mathematical operation on pointers, but not just for fun. It has a powerful practical uses, especially in array traversal and buffer manipulations. Operations allowed p plus plus r plus plus p means move to the next memory location. P minus minus or minus minus p means move to the previous memory location. P plus n means move n elements ahead. P minus n means move n elements backward. One of the example is there int array some array 10 20 30 int star p equals to array p plus plus. Now points of array 1 which is 20. Pointer arithmetic expect type sizes. Int moves in a 4-byte step. Char moves in 1-byte step. Think of a pointer like a black mark in a book. If P plus plus moves to the next chapter, not the next page. The size of the chapter depends on the data types. Incrementing and decrementing pointers. When we increment or decrement a pointer, we are not simply adding one, we are moving by the size of the type the pointer is pointing to. It's one of the example is there array. Array size 3 equals to 1, 2, 3. Int star pointer equals to array p plus plus semicolon now points to array 1. If int is 4 bytes, then PPP actually adds 4 to the memory addresses. But from our perspective, it just moves to the next array elements. Similarly, P minus minus moves back to the array 0. This is especially powerful when looping through arrays. For int star P equals to array P less than array plus P. P plus plus open the bracket printf percentage of D pointer P close the bracket. This pointer based iteration is faster and closer to the mission, often used in performance critical code. Adding and subtracting integers to pointers. This builds on pointer arithmetic. When you say p plus n, we move the pointers in n element forward, not n bytes, but n elements. Let's look at an example. Int array equal to 100, 20, 300, 400. In pointer array, in pointer q equals to p plus 2. Now we point to array 2 mean 300. Subtracting works in the same way. Q equals to p plus 2 and q equals to q minus 1. Now points to array 200. Pointer arithmetic change when dealing with the subarrays, matrix rows are skipping headers in data streams. Also remember one thing, subtracting one pointer from another gives you the number of elements between them. It differs array minus array 3 minus array 0 differs 3. This is just gives the bytes, it gives the count of elements. Pointer compression. Pointer can be compared using equal, not equal, greater than, less than, greater than or equal, less than or equal, but only if the pointer belongs to the same memory block, usually the same array. One of the example is there, int array equals to 1, 2, 3, 4, 5. Int pointer are equal to array. Int star q equals to array plus 3 if p less than q open the bracket, print p is the before q, close the bracket. This is useful when iterating through arrays without using index variables, while p not equal to q and print percentage d and pointer p plus plus plus. One of the warning is also that compression outside the bounds of the same array or allocated block is undefined. Always stay within the limit of the what you want. Type sensitivity in arithmetic. Pointer arithmetic is a type sensitivity. That means the amount added and subtracted depends on the pointer type. Let's compare int star ip, char star cp. Means adds size of int like usually 4 bytes. CP++ means adds size of chars always 1 byte. This matters because misinterpreting type lead to bugs. In memory manipulation or serialization, use caster to move byte by byte. Use int star or double star for logic data transfer. Let's say you mallow a block of memory. Void mem equals to mallow 20, char cp equals to char member cp plus equals to 5. Now point is 6th byte. This precision is why pointer types must match their data, especially when using the white stars or in a struct based data parsing. Passing by reference using pointers. In C, we don't have native pass by reference like C++, but we can simulate it using pointers. Why is this point important? Because if you pass a variable directed to a function, we are passing a copy, the function cannot modify the original variable. But if you pass the address a pointer, the function can modify the actual variable. Here one of the classic example is the void update int star n, open the bracket, star n equals to 20 and open the bracket. Now in main int a equals to 5, update ampersand a, printf percentage d a, output is 20. We pass the address of a, so star n equals to 20, change the original a. This is used heavily in modify arguments, swapping values and creating the linked list and trees. We can now understand why very serious C program needs pointers for function interaction. Example, swapping two values. This is one of the most popular pointers use cases, swapping two variables. Let's say to write this function white swap int star x int star y, open the bracket, int use the temp function equals to star x equals to star y equals to star temp, close the bracket. Here how it works in main. Int a equals to 10, b equals to 20, swap ampersand a ampersand b. Printf a equals to percentage d, b equals to percentage a comma b. A equals to 20, b equals to 10. Why does it work? X and y are pointers to a and b. We dereference them to swap the values and those memory location. Without pointers, swap x, y would only swap copies and a and b would not change. Iterative moment. Can anyone guess what happened if call swap a comma b instead of swap ambiguous a and ambiguous b? Answer: if or not work, it will just swap copies in local scope. So pointers enable direct manipulation of original data in functions. Returning pointers from functions. Returning a pointer from a function is possible and often useful, but you have to be careful. Never return the address of a local variable because it goes out of scope when the function ends. Example of what not to do. It star get pointer int x equals to 10, return ampersand x. What to do instead? Use static variables. Instead, get a static int x equals to 10, return ampersand x. Use malloc function. Same example is repeated, and returning pointer allows you to return arrays are struct. Build factory functions. Share data between functions efficiently. Best practices. Document ownership. Make it clear who should free the memory. Function pointer basics. Function pointer or pointer that store addresses of functions. Why would you need to that to call different functions dynamically? Implement callbacks, replace long switch case statements. Here's simple functions. Int add int a, int b, and open the bracket, return a plus b and close the bracket, and a pointer to it. Int function ptr, int a equals to add, calling it int results equals to function ptr 3 comma 4, output is 7. Think of it like function is building, the pointer is mapped to that building. We can follow the map to use the functions. Function pointers are heavily used in event driven systems. Main-driven program operating system kernels. They seem complex at first, but once we get the syntax, the use cases are endless. Real-world use case of function pointers. Let's bring function pointers to life with real-world scenarios. Callbacks in libraries. Libraries like QSort in C use function pointers to decide how to sort. Int compare constant white star A, constant white star B. QSort array n size of in and compare. Plugging systems. Load a function from a model or shared library and call it pointer, no recompiling needed. Replacing switch case. Instead of switch options, case 1, case 2. Use wide OPS star 2 equals to add and subtract OPS option 1. This is elegant, efficient, and dynamic. In embedded systems, drives use function pointers to abstract hardware. If you understand function pointers, you can ready to build flexible and scalable software systems. Array and pointer relationship. In C, the name of an array acts like a pointer to its first element. This means array is essentially equivalent to ambiguous or. Let's break it down. Int array equals to 10, 20, 30. In pointer equals to array. Here points to the first element of array. Accessing elements. Array 1 equals to star array plus 1. Pointer math lets you move across an array. In array, one of the using the loop int I equal to 0, int greater than 3, I plus 1. Open the bracket, print a percentage of d star array plus 1. Close the bracket. One important thing, array is not a pointer, but it decays into a pointer when you pass two functions. If you can't reason the array name like a pointer, array equals to array plus 1. It is illegal. Understanding this relationship is essential for pointers, arithmetic, memory manipulation, and writing clean and efficient C code. Accessing array elements using pointers. This slide reinforces how pointers can traverse arrays. Once you assign a pointer to the first element of an array, int array equals to 10, 20, 30. In pointer p equals to array, we can move through it. Print a percentage of d star p plus 1. print equals to 20. This is powerful because you don't need an index variable. It allows low-level memory operations. Work even if size is not known at compile time. Try this loop. You are directly using memory addresses to access values every efficiently. But be careful. Going beyond array bounds results in a undefined behavior. Make sure you know how many elements are allocated. Pointer to an array versus array of pointers. This slide highlights a common confusion in C programming. There is differences between pointer to an array int star p5, array of pointers int star p of 5, array of 5 int pointers. When to use which? Use int star p5 when you want to pass a 2D array row to a function. Use int star p5 when each element can point to a different array, like strings or rows of different lengths. It's a one of the example is there. Think of this slide as a fork in the reed. Choose the right structure based on whether we are pointing the whole block or individual pointers. Dynamic memory allocations. One of the most powerful useful of pointers in dynamic memory allocations. Giving your program the ability to request memory at runtime. In C, we use malloc, allocated memory, uninitialized. Carlo, allocated the initialized to 0. Reallo, resize previously allocated memory. Free means release memory. It's a one of the example. Int p equals to int malloc size of int. Star p equals 25 printf percentage d star p free p. We dynamically create a space for one int, store 25, then clean it up with free. Why is this useful? We can allocate memory based on user input, more efficient use of system memory, crucially for data structures like a linked list. Always checks if malloc function return null and never forget to free your memory, otherwise we will case memory leaks. Dynamic memory allocation example. This example shows how to dynamically allocate memory for an array where the number of elements is not known at compile time. Int n scanf percentage d ambicent n. Int array equals to int malfunction and star size of int. Here n could be anything. You only allocate as much as needed. Input for int I equals to 0, I greater than n, I plus plus, scanf percentage d array I. Output is there. After use free array. What's important thing is also that this is how professional application works. Web browsers allocated space for dynamic tabs, games allocated memories based on scenes complexity, OS allocates memory as program requested, make dynamic memory your all but treat it responsibly. Dynamic memory allocation. Example 3. This example shows how to allocate memory for an array based on its user input. Let's go through it carefully. Int and scanf percentage d n. Int array equals to int malloc n star size of int. We are using n star size of ints to allocate enough space for n integers. Then for int I equals to 0, I greater than n, I plus plus plus. Open the bracket, scanf percentage d and array I and. And finally, for int I equal to 0, I greater than n, I plus plus plus. Open the bracket, printf percentage d and array I and close the bracket, free array. Common mistakes. Forgetting to free arrays, misusing uninitialized values and allocating incorrect size. Example, forgetting size of int. Let's debug this code together. For example, what happens if malloc false? Always adds if array equals to null, open the bracket, and printf memory allocation fail bar n, return -1, close the bracket. This makes your code more reboot and production ready. 2D arrays and pointers. Working with 2D arrays of dynamic in C requires using pointers to pointers. Here what a 2D array look like. Int matrix 3, comma 4, 3 rows and 4 columns. But what if the size is not known at compile time? Use int star matrix equals to int malloc function rows star size of int. For int I equal to 0, I greater than rows I plus plus. Matrix I equals to int star malloc function calls size of int. Close the bracket. Now matrix ij works like a normal 2D arrays. Advantages: allocate memory based and needed, useful in matrices, graphs, tables, etc. Don't forget, free memory correctly. For int I equal to 0, I greater than rows, I plus plus 1, open the bracket, free matrix I, close the bracket, free matrix. Understanding 2D dynamic arrays is critical in simulation, image processing, and large scale data handling. Summary. Key takeaways. Let's pause and reflect on what we have covered today. It's been a deep dive in, and here are the key takeaways. Pointers gives you direct memory access, enable trace by reference, dynamic memory, and flexible data structures. Crucial for efficiency and performance critical code. Require catation, improper use can lead to segmentation, floods, and memory leaks. Used in arrays, strings, structures, function calls, and more. Ask Ask yourself, do you I understand how to declare and initialize a pointer? Can I use malloc and free responsibly? Do I feel comfortable with pointer, arithmetic, and arrays? Pointers are not just a feature, they are mindset. A powerful tool that gives you control over memory. Mastering them separates beginner programmer from system level developers. Quiz. Now it's time to test your understanding with a quick quiz and discussion. Question 1. What does star p plus plus means? Answer: it dereference P, then moves P to the next addresses. Question 2. How do function pointers work? They store the address of a function. We can call a function its pointer. Question 3. How to pass arrays to function using pointers? Just pass the array name. It declares to a pointer automatically while print int star a int star a. Discussion tips. Ask who wants to try a live code walkthrough. Show how a memory bug or leak appears using an example. Remember one thing, understand comes in not from memorizing syntax but from using the pointer. It's meaningful programs. Reference. To master pointers, theory is just the beginning. You need to practice and the right resources. Recommended books: The C Programming Languages by Kierkegaard and Richard, The Bible of C. Expert C Programming by Peter Van Linden. Great for advanced online learnings. Greek for Greeks. Tutorial points. CPPR reference. Practice ideas. Use let code or anchor rank for pointer based challenges. Rewrite your previous code using dynamic memory. Every Gate C++ program struggle with pointer at first. The key is to build, debug, and break things until it clicks. Thank you for joining this session and like, share, subscribe, and happy coding.